July 3rd, 2025. Julia is a freelance opinion writer and investigative journalist based from her suburban apartment just outside New York. She wakes up one morning to full sunlight, streaming in around the curtains and spilling across her bed. She stares for a moment, dazed, before realization strikes. There's no alarm. She's slept in. Her phone's been plugged in all night, but when she tries to unlock it, it remains black. She scrambles into the kitchen, and her appliances are similarly dead. She gives the light switch an experimental flip. Nothing. She trots to the living room and tries the overhead lights, the lamp, the TV. Dead. A few of her neighbors are gathered across the street, clustered around someone holding a cell phone. As she nears, she hears it emitting a series of beeps. It has juice, but there's nothing on the other end. No one has any power. Sockets have bubbled over and fused. Electric cars have short-circuited, and even the street lamps show signs of blistering or bursting, as if from a sudden overload. Of the devices that had been plugged into outlets, like phones or laptops, only a portion are turning on, and those that do don't seem to have any reception. They don't know it, but this is global. Similar scenes play out all across the world. Families are waking up to no power, pouring into the streets and piling into cars to make for the nearest store or city or gas station. Anywhere they might be able to stock up or find someone who knows what's going on. But it's not just civilians. Military are launching into emergency mode, and with limited communications, they are perilously close to panic. World leaders are meeting with defense departments, checking the status of nuclear launch facilities. Ships across the world's oceans find themselves abruptly alone, floating in a void of radio silence. Submarines surface in a desperate attempt to orient themselves, each on standby to attack. It's an EMP, of course, an electromagnetic pulse, and of unprecedented proportions. This is no mere military act. This isn't a simple nuclear detonation or an electromagnetic bomb. It's not man-made at all. This EMP came from the sun, and it's affecting the entire globe. It's caused by what is known as a CME, a coronal mass ejection. The magnetic field lines of the sun are constantly in flux, reacting to the magnetic activity generated and pushed outwards from the sun's core. Where this magnetic activity intensifies, it occasionally forms sunspots, distressed regions of the sun's surface in which induction is essentially smothered by the concentration of magnetic lines. As the magnetic lines react with one another, they form enormous arcs or loops, twisting or tangling and thrumming with energy. When the distress is too much, they snap, launching massive amounts of charged particles outwards, tearing through space at speeds up to 3,000 kilometers per hour. This is known as a coronal mass ejection, and if it happens to be in the direction of Earth, well, that's when our hypothetical 2025 scenario is all too possible. While a CME of the proportions described above has yet to strike Earth, astronomers suggest that it's only a matter of time. During the sun's least active period, known as a solar minima, there might be less than one CME a week. When it's most active, however, during solar maxima, CMEs occur several times a day. These can be released outwards in any direction, of course, so the probability is small that an individual storm will end up directly in Earth's path. Still, it is important to remember that these CMEs are happening constantly. Mathematically, some portion of them does strike Earth. We're only lucky the recent ones have been so mild. But can it last? The sun's cycle is set to spike in 2025, meaning until then, the frequency and intensity of CMEs is only growing. In 2012, astronomers detected a super-fast CME that just missed us by 9 days. Had it struck, it would have been the most powerful geothermal storm in modern history, likely more powerful even than the famous Carrington event of 1859. In 1859, the peak of electronic technology was the telegraph, and though it was quickly being integrated into civilization, we were hardly dependent on it the same way we're dependent upon electronics today. During the Carrington event, the Earth's magnetic fields were so thoroughly disrupted that telegraph machines sparked and started fires. Many operators received electrical shocks, while others found they were able to operate their machines even while disconnected from power. One team was able to continue business between Portland and Boston for over 2 hours. The northern lights could be seen as far south as Cuba, southern China, and even Colombia. But that was in 1859, before the internet, before household electronics, before cell phones, before airplanes and stoplights and electric vehicles. Just imagine if that storm had struck in 2012. We are implementing increasing numbers of safeguards to protect against such surges. We have telescopes trained to detect solar activity before it affects us. The slower CMEs can take days to reach Earth. The fastest ones, like the one that missed us in 2012, might reach us in 15 to 18 hours, meaning even then there is some chance to prepare. If we saw a CME incoming, power grids would be shut down. Satellites would have their antenna retracted, their more vulnerable wires shielded. Individuals would prepare as well. People would disconnect their electronics and shield them with aluminum. They would stock up on gasoline and generators and withdraw money from the ATMs. Consider, though, what this sounds like. People would be preparing for no internet, no power, no digital communication. We tell stories of events just a bit like this. We call them apocalypses. You take the power away, and what happens? People panic. We saw what happened during COVID. What might happen if people, nations, militaries found they couldn't go online at all, couldn't communicate, couldn't see what anyone else was doing? It's easy to imagine world leaders thinking about the big red button, wondering if hostile missiles are already on their way. It's easy to imagine supermarkets stormed, supply chains severed, each community and nation scrambling to keep its resources for itself. What sort of reliability would money have in such a situation? Would people trust it? What might they do if they did not? Had that CME struck in 2012, this might have been the outcome. Now, though, we've had more time to prepare, so let's look at the bright side. Suppose our precautions pay off. The power grids are all shut down beforehand. We all stock up on food, unplug and shield our sensitive electronics. The storm comes, but things are less grim. Some long power lines are fried, switches overheat and fuse, and satellites malfunction. In this case, when the magnetic disturbance ends, we simply set about restoring power, replacing switches, restoring breakers, reinstalling the fragile wires which port power long distance from our sources to our cities. The infrastructure would still largely be there. Roads and bridges and factories and heavy machinery, planes and boats and farms and all the concrete framework of a functioning civilization. All we need to do is replace the damaged electronic parts and get the turbines turning, the coal burning, the solar panels basking in the sunlight. Experts estimate damage upwards of $2 trillion and at least 10 years needed to recover. But they say we would most definitely recover. As long as we prepare, and as long as we don't panic and destroy ourselves in darkness, humanity can meet the next geothermal storm with something resembling readiness.